Welcome back to Master Academy of Mathematics. This is the next video session on higher order ordinary differential equation. Here we are going to calculate particular integral yp. The first method is, if the right side q, it is looking like e power ax. So whenever right side looking e power ax, then you can apply this particular procedure. So I just give you the procedure. Represent the given higher order ordinary differential equation in the symbolic form. That means f of d of y equal to q. Then you are calculating auxiliary equation by f of m equal to 0. Find out the roots, then find the yc, it is the complementary function, by using the auxiliary equation. And find out yp, the procedure is 1 divided by f of d of q. That means 1 divided by, write down f of d, q means e power ax. So this is equal to 1 divided by f of a. That means d is replaced by a, directly e power ax as it is whenever f of a is not equal to 0. If not equal to 0, then only you can write down directly d is replaced by a value. Suppose if f of a is equal to 0, then the same f of d you are splitting into d minus a whole power k into phi of a. Then you are substituting in that particular factor where you are getting non-zero. The remaining factor directly you can write 1 divided by d minus a whole power k phi of a e power ax. This formula is applicable when f of a is equal to 0. When we do the problems, you can understand easily how you are getting the yp values. So after getting yp, find out the complete solution y equal to yc plus yp. This is the first procedure when the right side looking like e power ax. Now let us have a problem. Solve d square y by dx square plus 4 dy by dx plus 3y equal to e power 2x. So look at this problem. This is higher order ordinary differential equation. Here the right side is looking like e power ax. If it is equal to 0, you calculate only yc. Since the right side is present looking in the form of e power ax, first you apply your procedure that should be represented in the symbolic form. Symbolic means, let us start with capital D equal to d by dx. Once you are using this differential operator, therefore the given equation you can write d square y plus 4 dy plus 3y, that is equal to e power 2x. Or I can write d square plus 4d plus 3 of y equal to e power 2x. This is looking like f of d of y is equal to q, where what is your f of d? It is d square plus 4d plus 3. And what about the q value? E power 2x. This is looking like e power ax. What is the a value? It is equal to 2. So once it is represented in the symbolic form, now you write down auxiliary equation. What is the auxiliary equation? F of m equal to 0. That means in your f of d, d is replaced by m, so that m square plus 4m plus 3 equal to 0. So if you want, you can use your calculator to get the values. How many values you are getting for this? 2 values. So minus 3 and minus 1. You can use your calci to get directly its values. Look at the roots. Are they real or complex? Both are real, distinct. So the roots are real and distinct. Therefore you can write yc equal to c1 e to the power of minus 3 into x plus c2 e to the power of minus 1 into x. So this is about your yc. Now to get your yp, I am just calculating yp equal to, as per the procedure, 1 divided by f of d of q. This is 1 divided by, what is your f of d? That you can write d square plus 4d plus 3. And q means your right side, it is e power 2x. Now what is your procedure? That d is replaced by a value. What is the a value? 2. So directly substitute here. 1 divided by, it becomes 2 square plus 4 into 2 plus 3. That e power 2x as it is. It is equal to 1 divided by 4 plus 8 plus 3 e power 2x. So 1 divided by 12 plus 3 is nothing but 15 e power 2x. So this is very easy. D is replaced by a value when you are getting f of d is not equal to 0. If it is equal to 0, we will take another problem. So after getting yp, therefore complete solution y equal to yc plus yp. Write down your yc. C1 e power minus 3x plus C2 e power minus 1 into x plus yp stands for 1 divided by 15 e to the power of 2x. This is the complete solution of given higher order ordinary differential equation. Now let us have another problem, somewhat different. Solve d cube minus 5d square plus 8d minus 4 of y equal to e power 2x. So it is right side looking like e power ax type. So directly I am using the procedure. The given higher order ordinary differential equation you are representing in the symbolic form. That means f of d of y equal to q, where what is your f of d? It is d cube minus 5d square plus 8d minus 4, and q stands for e power 2x looking like e power ax, where a is equal to 2. Now you are calculating first auxiliary equation. So for your practicing purpose, I am just giving you, it is f of m equal to 0, directly m cube minus 5m square plus 8m minus 4 equal to 0. You can use your calculator so that you are getting the answer only 1 and 2. So actually we require 3 values for m. So 1 and 2 you are getting means one of the roots it is repeated. How to calculate the repeated value? Use your synthetic division method. Already we have taken in the last video sessions. So repeated value you can calculate. That value is nothing but 2. So totally the roots are 1, 2, 2. Roots are real or complex? All the roots are real and few roots are repeated. So therefore you are calculating yc equal to, first you focus on repeated values, c1 plus c2x into e to the power of repeated value 2x plus c3 e to the power of next root 1 into x. That is about your yc. Now to get your yp, the procedure is yp equal to 1 divided by f of d of q. It is 1 divided by your d cube minus 5d square plus 8d minus 4, and q means e power 2x. Now directly if you substitute d equal to a value, will you get 0? That 0 or non-zero can be identified. Just you look on to the a value. Is this a value present in the roots? Yes. So when the a value is present in the roots, definitely you will get this denominator is equal to 0. So automatically you are getting 0 here. When you are getting 0, better you write down in the factors. That factors can be written based on the roots. The roots are 1, 2, 2. So in order to write down the factors, d minus 1, d minus 2, d minus 2. This is the way of writing the factors by using the roots. That e power 2x as it is. It is equal to 1 divided by d minus 1 into d minus 2 whole square, and it is e power 2x. So after writing in the factors, now you substitute the a value in non-zero factor. So where you are getting non-zero? Here you are getting non-zero. This is nothing but 0 value. So first you write down in the non-zero factor, it is 2 minus 1. That a value is substituted in the place of d. So this value, and don't substitute in the 0 factor. That answer is nothing but directly x to the power of, what about the x power value? Your x power value, here power is there 2, that is divided by 2 factorial. So x power k divided by k factorial, and this e to the power of 2x you are just writing as it is. So this is the procedure when you are getting that denominator value is equal to 0. So once you get this value, therefore you can write down y equal to yc plus yp. That is your final answer. Now let us have certain exercise problems when the right side looking like e power ax. The first problem, d cube minus 6d square plus 11d minus 6 of y equal to e power minus 2x plus e power minus 3x. Only the thing is, first you calculate yc. when you are coming to yp, 1 divided by, write down complete f of d of y. Q means this is your right side q value. So that q value you are just separating. For this, 1 divided by f of d into first one plus 1 divided by f of d into second one. So both are looking like e power ax. Directly substitute and you will get, this is your complete solution. Okay, this is yc and that is your yp. Second one, d square minus 3d plus 2 of y equal to cos hx. It is a hyperbolic function. What is the formula for cos hx? We have a rule that e power x plus e power minus x divided by 2. That is the formula for cos hx. So 1 by 2, it is a constant term. You can take it outside. After getting your yc, again you split that yp in two parts. 1 divided by f of d into e power x plus 1 divided by f of d into e power minus x. Just you will get, this is your yp. And the next problem, d square plus 5d plus 6 of y equal to e power x. So direct procedure and looking e power ax type, after getting yc, and this is your yp value, e power x by 12. Next problem, d square plus 6d plus 9 of y equal to 2 e power minus 3x. 2 anyhow it is a constant. So after getting your yc, while finding yp, 2 you can take it outside and only you are calculating e to the power of minus 3x. For that, directly you will get the answer yp is x square into e power minus 3x. So these are the basic important problems when you are entering into right side looking like e power ax of the given higher order ordinary differential equation. So in the next video session we will take the next right side, it is looking like q equal to either cos ax or sin ax. Based on that we can enter into the problems. Have a good day.